With so many different technologies and clamp meter models available on the market, selecting the right product for the job is essential. Some have too many features you don't need, and poor performance from the ones that you do. Fortunately, the clamp meter models from Martindale make it easy by focusing on features needed for common applications and ensuring performance, reliability and accuracy in these areas. Essentially, they all measure the magnetic field generated by the current flowing through the conductor. The jaw of the clamp forms a magnetic circuit around the conductor, and the magnetic field is measured through a current transformer wound around the jaw for AC currents, or a Hall effect sensor built into the jaw for DC currents. The clamp meter then does the clever stuff and displays the actual value of current flowing in the conductor. With low quality meters, the position of the conductor can cause large errors in readings, and in this case it's always good practice to keep the conductor centrally positioned. Equally, conductors carrying high currents outside the jaw but next to it can cause large errors in readings if the magnetics design and assembly is poor. When measuring current flow within a conductor, it's important to only clamp around a single conductor, which for multi-core cables may mean splitting out the conductor from the rest of the cable. Clamping around earth, line and neutral in one go will give a zero reading, as the magnetic fields from the conductors cancel each other out. The exception to this rule is when troubleshooting for leakage currents, typically at milliamp levels, and often the cause of nuisance RCD tripping. In this case, clamping around the line and neutral together will measure any imbalance caused by leakage currents. Now this requires the use of a specialist leakage clamp meter, such as the Martindale CM69, which is explained in another video. To help choose the right product in your category of clamp meter, here is the essential checklist. The minimum and maximum current levels, the safety installation category rating for your application, the resolution and accuracy to accurately measure the minimum level of current, jaw size for access and maximum conductor size, AC only current or AC and DC current, ease of use including features such as auto ranging, backlight and thumb wheel for function select, any additional functionality including AC-DC voltage, resistance and min-max recording, and True RMS measurement. True RMS is becoming even more important with the increased use of modern low-energy lighting systems and power supplies, which generate harmonics and cause distorted current waveforms. Basic clamp meters without True RMS capability are calibrated for the measurement of sine waves only and will give large errors on distorted current waveforms. Errors will depend on the levels of harmonics and can lead to readings 50% lower than the actual value. The size of the errors will vary depending on the level of harmonics at the time, making comparative measurements impossible. Having completed your checklist, it will make it a lot easier to choose from one of the 4 categories of clamp meter available. First, there are electrical testers with basic current measurement capability, such as the ET4 and ET5. Essentially general-purpose devices that you might use for installation testing and fault finding, with the added benefit of AC-DC current measurement through a fork design, which can be useful in tight spaces. The ET5 can even measure temperature and capacitance. The second category is pocket-sized, high-performance AC and AC-DC clamp meters, where the primary function is current measurement. Martindale models range from the CM51 to CM79. These provide high accuracy measurement over a wide current range for electrical contractors, maintenance teams and installers in residential, commercial and industrial applications. All will resolve current readings to 10 milliamps and are auto-ranging. Most are True RMS, have backlit displays and will also measure AC-DC voltage, resistance and continuity. The AC-DC capability of the CM79 makes it ideal for solar power installations, electric vehicles, battery testing and UPS systems. Additional features like min-max recording are useful for troubleshooting peak and residual loads. Being True RMS means you get very accurate, reliable readings with distorted waveforms, caused by electronic controls for motor drives and lighting. For more specialist high current applications, there's the CM82 to CM87. These have large jaws with a Cat 4 safety rating for supply-side applications and are suitable for use on buzz bars in industrial and utility applications with current ranges up to 2000 amps for AC and DC applications. The fourth category is lightweight, flexible current meters, such as the CM95 and CM100, enabling access to difficult-to-reach and large conductors where conventional clamps just can't go. The smaller flex of the CM95 will resolve down to 1 milliamp, whereas the large diameter flex of the CM100 will measure up to 3000 amps. And both, of course, can be used around multiple conductors for leakage current investigation. In contrast to conventional CTs, they cannot be overloaded. So we can see, whatever your need and application, Martindale make it easy to choose the right current clamp, whether it's for low current AC, DC for solar PV and battery systems, or leakage current measurement. The CM series get the job done.